Hi, welcome to part 2. I'm just going to quickly recap short division here. So we've got 76 divided by 5. So I'm just going to do this pictorially. So there's our bus stop. And we've got divisor is 5, dividend is 76, and the quotient will be the answer up here. So in black, what I'm going to start with is 7 of these. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And now I'm going to turn them into groups of 5 because that is our divisor. So there we go. Quite clearly, I can't make another group of 5 here. So there's one complete group of 5 that goes up here. Now I've got these 2 left over. So the exchange rate is 1 for 10. So therefore, if I've got 2, I'm going to have 20 in the next column. So let me just write out 1, 2, 3, 4, 5, 6. So the black is representing what's there, or what's in the dividend already. And these 2 will both exchange for 10 each in the next column. So obviously I'm going to need 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If I just look at the abstract now, okay, we look at 7 divided by 5, which is 1. You're going to get one jump of 5 in. So that's where the 1 comes from. 5 times 1 is obviously 5. 7 was our original number. The difference between 7, our original number, and 5 is 2. So if you're doing this abstract, the 2 would exchange for 20, and here we have 26. So that is where I've got my 26 dots from here. Now I'm going to turn these into groups of 5 because that's our divisor. 5, 5, 5, 5, and another 5. Brilliant. So here we've got 1, 2, 3, 4, 5 clear groups, 5 complete groups. So that's our, so that goes as the quotient, and there's 1 left over, but because there's no more digits, that becomes our part of our remainder. So that whatever is left over, the remainder becomes the numerator of the fraction, and the divisor becomes the denominator. Okay? This process obviously gets a bit long-winded if you get some large remainders, larger numbers, but it's just early on in the division sort of journey, it's good to see pictorially where these exchanged digits are coming from. So we have the 2 left over here because we only used 5 out of that 7. So they exchanged, that would exchange for 10, and that would exchange for 10 into the next column, which is where I got my 20 from. I'm just going to rub this out so I've got a bit of space. The short division process with decimals doesn't change. Okay, I'm going to draw my bus stop again. My dividend goes underneath 254.6, and my divisor goes on the outside of the bus stop. The quotient will go on the answer here. Don't get confused that there is a decimal point. Okay, it's the process exactly the same. Okay, so let's go through it step by step. 2 divided by 3, that's the first step. 2 divided by 3, you clearly can't do it because 1 jump of 3 would be 3, and we've only got 2, so you put 0 there. 3 times 0 is 0, so the difference between 0 and 2 is 2, so that is what gets exchanged. There's 2 left over. So now I do 25 divided by 3, or 3's into 25. So 3, 6, 9, 12, 15, 18, 21, 24, gives me 8 jumps. 8, I got to 24, 3 times 8 is 24. The difference between 24, where I got 2 in my jumps, and 25 is 1, so that's 1. There's exchanged. So now I do 14 divided by 3, or 3's into 14. 3, 6, 9, 12. I can't go to 15 because I've only got 14. So that's 4 jumps. 3 times 4 is 12. The difference between 12 and 14 is 2. So that's how many are left over. So that's where my exchanged 2 for 20 over here. Now let's not forget we've now left over a decimal point, so the decimal point needs to go into the quotient as well. So now we have 26 divided by 3. So that's 3, 6, 9, 12, 18, 21, 24. We can't go to 27, so that is 8 jumps. 8 times 3 is 24. The difference between 24 and 26 is 2. You exchange a 2 for 20. There's nothing here which can be represented as a 0. So now I would do 20 divided by 3. So you can go 3, 6, 9, 12, 15, 18. We can't go to 21, so that is 6 jumps. Okay, 3 times 6 is 18. There's 2 left over, 2 remainders. That's exchanged for 2. 20 here, and now I'm spotting a pattern. I think this is just going to keep going. So 20 divided by 3 is 6 again, with 2 left over, but I can just see that is going to repeat itself, so it's recurring. So you could just put dots above those and say it's going to recur, but the process hasn't changed, okay, for the decimal part, just because you're dividing by decimals. Something I would like to highlight now is a classic SATs question where the children usually do some fantastic division, short division, but they don't actually answer the question properly. So here we go. We've got cake boxes can hold 6 cupcakes. Boss Bakery made 235 cupcakes today. So how many boxes did they need? Children are usually very good at identifying that actually, well, we've got 235 cupcakes. And they are put into, they are shared into boxes, and each of those boxes holds 6. They can see it's divided by 6. So if we put that into a bus stop, 235 is the dividend, and the divisor is 6. Quotient will be how many boxes are needed. So again, let's do this. 2 divided by 6 you can't do, obviously because one jump of 6 would be 6. So we can put 0 there. So 0 times 6 is 0. The difference between 0 and 2 is 2. So that's where I get my 2 to exchange for 20. So I now have 23 in the next column because I didn't use any of those, either of those 2 in there. So now I've got 23 divided by 6. 6, 12, 18. Can't go to 24, so it's 3 jumps. 3 times 6 was 18. Like you just heard, 3 times 6 was 18. The difference between 18 and 23 is 5. So I have 5 left over, 5 remainder. So that is exchanged for 50 in the next column. So I now have 55 in the next column. So now back to our 6 times table. 55 divided by 6, or 6 is into 55. 6, 12, 18, 24, 30, 36, 42, 48, 54. Can't go again. Okay, so that's 9 jumps. That's 9 steps. 9 times 6 was 54. The difference between 54 and 55 is obviously 1. We've got no more digits to work out, so now we start looking at the remainder. So there is 1 remainder here. Okay, well, like I said before, what is the remainder left over becomes your numerator, and your divisor becomes your denominator. So 235 divided by 6 is 39, remainder 1/6. But need to apply some sort of common sense here. So there was 235 cupcakes made. Boxes hold 6 cupcakes. So what a typical error here is that children would put the whole number. They put, right, well, we need 39 boxes, remainder 1/6. Well, what does remainder 1/6 mean as a box? Okay, you're not going to suddenly at the end of the day just cut the cupcake boxes into 6 parts and just take 1 part, are you? Okay, so the question will be, how many boxes are needed? So it's not 39 boxes, because you've obviously got this 1 cupcake left over. What are you going to do with it? Poor cupcake. So you need 40 boxes in order to box away all of these cupcakes that were made by Boss Bakery. So it's a common error with children, is just seeing this whole number here and running with that, and all writing 39 remainder 1/6. because that doesn't mean anything in terms of the question. It's brilliant mathematical skill here, but applying it to the question, you can't have 1/6 of a box. Well, you can, you'd have to cut it up, but that would be silly. So these questions can manifest themselves with sort of footballs in a bag. You know, a bag can hold, I don't know, 8 footballs, but you've got 45. How many bags do you need? Those sorts of questions. Classic ones as well as school trips on a bus. So a bus can hold 50 people, but there's 437 children. How many buses do you need? Children will go for, what was it, 8 whole buses and 37 over 50 remainder. If they just put the 8 buses, well, they've left 37 children back at school or in the museum. So it's just applying a little bit of common sense to the question here after doing this really successful mathematical process there. I hope that helps with your questions. Oh, and if you'd like a challenge with a bit of, here you go. Just leave that on there so you can pause it, and I'll stop the video in a couple of seconds.